ideal relation or ideal relation or whatever you call it. Now, first things first. Why are you having this session? Quickly. Already you have submitted your mini projects in place. You believe it or not? Nowadays, the most important thing what is going on around it, some of you have, I think, where is the area on the street? Anyone from the area on the street? They have gone for to represent the college. Believe it or not, last time when we had a session at Manipal Bootcamp, where they had presented their ideas. In Namtira Vidya, second year MIT students, their projects, even in the Dhoni, they are building working models out of it. They are manufacturing it. They are in collaboration with some industries because MIT has good contacts and they have their own incubation centers. And what they do is they collaborate with some of the industries and they manufacture stuff. They manufacture their own casing. They manufacture their own, they are into hardware and software. From scratch they are building. For example, what is that you use? I think you use Pixoc for the controller part. They develop their own. Because they have their own software which cannot be integrated into the existing hardware. So they have developed their own hardware, they have developed their own software. And when we were casually speaking, we asked some of your juniors at we casually asked them, how did we start with it? They simply said, sir, we had an idea. I did not know anything about electronics. I am from aeronautical background. But my hostelmate over there, he was good with electronics. We came together, we sat together, night times we used to sit, we used to discuss, and finally we started working on it. We had some of our mentors to guide us. We went to the production team, they helped us with the PCB design and all those things, and finally the product is ready. Now they are into their third year, but they all started with their second year projects. Good ideas always have a humble beginning. Remember, ಯಾವುದೇ ಪ್ರಾಡಕ್ಟ್ ತಗೊಳ್ಳಿ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಿಮ್ಗೆ ಆ ಪ್ರಾಡಕ್ಟ್, ವಾಟ್ ಇಸ್ ದಟ್ ಪ್ರಾಡಕ್ಟ್, ಯಾವ ಏರ್ ಫಿಲ್ಟರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡುವಾಗ ಅವರು ಕೂಡ ಇಂಥದ್ದೇ ಇದರಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಕಾರ್ಡ್ಬೋರ್ಡ್ಸ್ ಎಲ್ಲ ಇಟ್ಕೊಂಡು ಅದಕ್ಕೆ ಸೆನ್ಸರ್ಸ್ ಅಲ್ಲಿ ಅಟ್ಯಾಚ್ ಮಾಡಿ ದೇ ಕನೆಕ್ಟೆಡ್ ಟು ಆರ್ಟಿನು ಇಂಥದ್ದೇ ಆಗಿದೆ. ಅವರು ಒಂದು ಚಿಕ್ಕದೊಂದು ಇದರದ್ದು ನಿಮ್ಮ ವಿಂಟರ್ನಲ್ಲಿ ಒಂದು ಮಾಡಿ ಸೇಮ್ ಪ್ರೋಸೆಸ್ ಚಿಕ್ಕ ಮಾಡೆಲ್ ಮಾಡಿದ್ದಾರೆ. ಸೇಮ್ ಪ್ರೋಸೆಸ್. ಒನ್ ಪರೀಕ್ಷಿತ್ ಅಂತ ಒಂದು ಕ್ಲಬ್ ಉಂಟು. ವಾಟ್ ದೇ ಹ್ಯಾವ್ ಡನ್ ಇಸ್ ದೇ ಹ್ಯಾವ್ ಡಿಸೈನ್ ಆ್ಯಂಡ್ ಡೆವಲಪ್ ಕ್ಯಾನ್ಸರ್ಸ್. I think some of you have worked with CubeSats. They have developed cancers. So, chikkal cylindrical chemical structure cylindrical. More hanta ಮಾಡಿದ್ದಾರೆ. On the first phase, they are focusing on sensors. Second one, they are focusing on data acquisition. And third one is something else. And they have a parachute which they have designed on their own in-house. And they are in collaboration with ISRO. They are sending it to the lower Earth orbit, and they are sending it. They are dropping it from there. And they will be collecting the data at every level of finding. Such sophisticated. But when we ask them, they say everything is started from scratch. So why in a hurry, why we went with this particular idea session? Whatever mini project idea you have, whatever it is, whatever you have presented in the last semester, right? Please present it again over here. But this time, whenever you are presenting, or even after today's presentation, please think about it being developed as a product. I think I have posted in, I don't know how many of you have seen, in your WhatsApp group, in your official WhatsApp group, I posted a message. Whenever you get time, in both automobile as well as aeronautical, go through. In the month of March, next month, we have a idea boot camp which is being organized by Battle Incubation Center at LinkedIn. Other than Spark and all. What they do is, you just need to go over there, present your idea. That's it. You need not have a working model like this. If you have an idea, just go there.
So, our team has developed a machine learning based surveillance drone. So, the main purpose of the problem that we taken is it is used for the detection of anti-poaching. So, as we know, in the recent times, the poaching activities are more increasing. So, the only way to control the poaching is to have a 24/7 have a surveillance over them. But the main problem is to have a surveillance, to have an eye over the forested area, we need a manpower. So there are, if we introduce a manpower, there are the chances that even the protectors or the rangers are getting harmed by the poachers. So we are trying to replace the manpower with this drone. So what we developed is an open source drone. Using open source parts, we developed the drone. So it is autonomous drone. So if you have a forest area, so in the software we can give the waypoints like location. This is the location, boundary location. So the drone will fly over to that exact location over there and run a surveillance over there. So if any poaching activities, like if a person holding a gun or if anyone is hurt, we can detect over there. The fourth one. So, for the detection and machine learning process, we use the microcontroller Raspberry Pi. So, this Raspberry Pi is integrated to this drone. So, it is a flight controller Pixel and open source flight controller. So, this flight controller, this drone is guided by the microcontroller. And if any poachers or any illegal activities were detected, the initial report will be sent to the respected officers. So that was our project. So we use the all open source resources. Like we use for machine learning purpose, we use the LoRa model, and also for the flight control management system, we use the Vision Planner software for the navigation and flight management. So that's it all. That's all of our project. Any questions?
Project title called Panel-Based Smart Runway Crash Detection. Runway is the most critical aviation operation where uneven detection of crash leads to a catastrophic damages. So our project mainly focuses on the smart runway sensor embedded system which detects a real-time crash detection, which leads to alert to the authorities to break down the uneven crash detection. So here we have implemented IoT project which mainly focuses on the detection of crash in runways. The main object is we have divided the runway into panel based, where we have implemented our sensors called FSR sensor, which is called as the force sensor, which detects the uneven load which leads to the crash, and it will alert the system that crack has detected, which leads to major notification that the crack has detected, and we can maintain the predictive, which can be done predictive maintenance. Here we have used components like wood, ESP32, FSR sensor, LCD display, which displays the whether the crack has happened and also how much load has implemented. Thank you. Here we constructed a runway using wood because as of now we have developed a prototype. So we have used wooden of size 300 into 100 and 50 mm, and inside we have implemented a FSR sensor which detects the load, and in code we have implemented put a limit of certain load. When the load reaches limited load, it will detect as crack detected. And we have used microcontroller as ESP32. You may raise a question that why you have used ESP32, because in ESP32 it has a Bluetooth capability compared to Arduino. In Arduino, some of the sensors can't be implemented as it has a limitation of power input. So we have used ESP32, and we can also implement the Bluetooth, etc. And coming to the component part, we have used force sensor and LED display and a motion sensor. It is an exceptional case. The main sensor is FSR sensor. This is the experimental setup which we have integrated. That is ESP32 LCD display, and that is a buzzer which will give a beep sound when crack is detected. These are the components which we have used. This is the output which will display as it displays force, as well as if the crack is detected, it will give a notification that is crack has detected. This is the outcome of our project. Thank you.
Dynamic we use castor oil, coconut oil, and isopropyl alcohol, it is technically feasible. And LP is used because of to reduce the viscosity, as castor oil and coconut oil are higher viscosity. Our project next one is we have planned to test in IC engines and jet engines, and to create AI model and chatbot also. And next one, application automobile industries and future implements testing in real jet engines and gas turbine engines, development of sustainable aviation fuels, and improving combustion efficiency and reducing emissions, mass scale production for aviation and automotive user, certification for aviation fuel standards.
Good morning everyone. So today we did a prototype which is air filter indicator. The introduction is about if you all know the air filter are implemented in vehicles. So why we need to change the air filter? Because if the air is not proper to the engine efficiency and knocking system and everything will be wrong. So we made such that to show the indicate which the proper air comes from the one point of the there is a one prototype. So let's do it. So from here the air will come, and by passing from the air sensor which is pressure sensor, and by here there will be a meter, there will be a air filter. So the proper air when the outcome it shows normal. When the dust is when the air condition, so it shows like we need to change it and we need to replace it. So that the air from which air comes from there, it should be like constant. So we made such as when the it is showing like what we say in front of the indicate, there will be a color, like there will be a green, red. So green is a proper on the air is passing feels blue way. But when it comes to red, it shows that we need to change the meter. So this is our it's like we can
ಯಾಕೆ ಹೇಳಿದೆ ಇದು? ಯಾಕೆ ಹೇಳಿದೆ ಹೇಳ್ತೀನಿ? ಯಾಕೆ ಹೇಳಿದೆ ಹೇಳ್ತೀನಿ?
So, good morning everyone. Myself Shreya, and we are here to present about analysis of hybrid electric regional aircraft. So, our project we are mainly focusing on to improve the fuel efficiency of regional aircraft. So, nowadays regional aircraft consumes large amount of fuel because of short route takeoff and landing. Then we have selected ATR 72 as a baseline aircraft. It carries 70 passengers. Its range is about 1,528 kilometers, and it uses two engines of PW127M turboprops. We have used open source software that is OpenESP. We have imported this aircraft model. Then we had configuration of placement in parallel hybrid, where we use gas turbine and electric motors, and we used like future battery, lithium air batteries. We considered three stages: one 750, 1000 and 1500. The next working will be explained.
These are the graph outcomes we have got when we simulated during in SWAP software. These are the outcomes.
Explain what exactly the graph is.
This is the graph. First one is battery mass versus supply power ratio. It's basically about the battery mass. How battery mass increases, the power ratio also increases significantly, and fuel mass and power supply power ratio. How the fuel mass decreases, the power also decreases. This is the NTOM versus supplied power ratio. NTOM means maximum takeoff mass, which comes in a straight graph. Like as the increase of maximum takeoff mass, also supplied power ratio decreases. And the NTOM versus power ratio, hybrid electric power. And battery masses versus supplied power ratio. This significance about the battery mass increases, supplied power ratio also increases due to that. We conclude that from the graphs that as we put the fuel decreases and battery mass increases, and due to battery mass increases, the MTOM, that's maximum type of mass, also increases. And we conclude that hybrid electric propulsion was significantly reduces fuel consumption and also in regional aircraft.
We had a lot of discussion, but my questions were clear. Suddenly I got this. See, you have mentioned like 1528 is the range. Can you able to be or build some relation between this, because you said like hybrid and where reduce fuel consumption. Can you able to link this inform? See, fuel consumption reduces. So automatically the range has to increase. These range calculations can be able to do that.
Basically, this is a pilot study of rockets. Here we explained everything we needed to learn as a project. But unfortunately, we are unable to finish that. This is not all. Everything we need to read. Here, we did analysis of every aerodynamic aspects of the aircraft. And this is done by using the basic aircraft. Which is the product of NASA. So this is the and we took the reference aircraft which is the airline is in the India's airline group, and we will bring this is because this is basically used as a engine aircraft, and we are implementing our project engine aircraft because of the battery package and this is explained by Nida.
mention something within this drone. The block diagram about it. Gesture sensor, we use microcontroller, wireless communication model, and drone receiver model. In that, we used two softwares, PyCharm and Arduino IDE. And by using the Python code, we inserted the MPU 650 and ESP32. That is for gesture. And using LDR, the up and down control should be hand. And we implemented only the up and down, left and right. And up and down range should be controlled by the TOF sensor, total of flight sensor, that range about 200 meters. And we have this industrial application, crop health checking, film making, tourist attraction, and kids STEM toys. Mainly purposes farming and kids can use the drones. Features for better to more accurate gesture detection. Smart flying in advanced we can't implement it. In future we have to do. Right? Bigger use is farming industry, cheaper, easy for everyone use, and smart, longer distance.
The main problem is that we are switching to EV cars, but we using we charging our cars from the power grid, which you consume the fossil fuels. It is not completely green. We have to. The main methodology is the renewable energy solar and wind energy. For solar energy extraction, we use the solar panel, and wind energy extraction, we use the wind turbine. Solar panel from DC to DC boost converter, it will boost the current, and in wind turbine we produce the AC current only. So we have to convert the AC current to DC converter. Then boost the DC current. Then it will directly come from the battery. We have to manage the battery from the battery management system. And then it will go to the electric standardization. Then it will go to the EV vehicle for charges. This is the main block diagram. We have taken from the reference papers. Here, this is the wind turbine and the solar subsystem. The subsystem is this, solar subsystem is this. Wind energy power output, then energy storage system from the solar subsystem, then rectified just DC to AC conversion blocks. Then it will go to the electric charging station. Working model is we have to extract the energy from the solar and wind energies, and we have to centralize that energy in the one battery. We can transform to EV vehicles to the EV vehicle charging station. This is the overall graph. In daytime we get solar energy more, and in day and night time we get the wind energies. The future scope is we have to maintain the battery state from the solar and wind energy electricity. We have to include the A power grid to maintain the battery state.
So why not one of charge? Income of charge.
ಅದಕ್ಕೆ ಕಾರಣ ಮಾಡಿದೆ.
ಅದು ಅದೇ ಕಾರ್ಡ್
ಹೋಟೆಲ್ಗಳಿಂದ ರೂಮ್ಗಳಿಗೆ ಕಾರ್ಡ್ ಇದ್ರೆ ಮಾತ್ರ ಲೇಟ್ ಆಗುತ್ತೆ.
ಅದು ಯಾವ people follow the person. How exactly that connection to will happen? Some method is there. That is good. Then you can say that what you are doing this is why not you try to get real good. You won't exactly do it. But if you are valid for the real model,
Currently, automotive industry is moving to EV. Current problems faced by automotive industry is the so basically, every vehicle carries some of those charge. There will be a range anxiety for the consumers buying vehicle. So that the emergency situation when the vehicle is off, then we can make to plan folding flexible solar panel, which gives almost 20% of efficiency. Charging the vehicle 5 to 10 kilometers to reach next charging station.
So, that's the correct way. So, the problem is the range. Nowadays, we are shifting to electric vehicles, so we are not getting enough range. So, when the vehicle battery depletes completely, we will use this secondary battery to reach next station in the emergency system. So this battery will be charged with using secondary battery will be charged using the solar panel while the car is parked at some, when we are parking the car at the college and parking of a car, so we can charge at that time the secondary vehicle. It needs 5 hours of charging to get the range of 25 kilometers. We did the simulation. We didn't do the model. It's a simulation. So this is a simulation done using HTML. Using HTML we did this simulation. So, yeah.
So how you
Will completely turn on secondary after utility.
So main battery is not like completely direct second battery. Second battery, one battery is sufficient. So is it what so what is the battery?
Normal battery will be
No, which is important? Voltage is important or amps is important or wattage is important?
Our topic is wireless electric vehicle charging. Basically, wireless electric vehicle charging enables power transfer without cables, but challenges are like energy losses and high initial cost and coil alignment issues. This problem is important because EV adoption is growing rapidly. So, convenient and safe and efficient charging infrastructure is necessary to charge the vehicle. So, the targeted users is including EV vehicle owners and automotive manufacturers and smart city planners and the renewable energy industries. So, improving wireless charging can enhance user convenience and reduces maintenance compared to the plug-in charging system. In that dimension, develop a cost-effective and high-efficiency wireless EV charging system with improving alignment of the tolerance and clearance safety. So this is the block diagram and that is prototype VT. Working of the wireless charging. So a charging pad is installed the ground and is connected to the power supply. When the EV is parked over the pad, the receiver coil fitted under the vehicle. The vehicle aligns with the transmitter coil. After that, alternating current in the transmitter coil creates the magnetic field, electromagnetic field. So this magnetic field transfers energy wirelessly to the receiver coil. The receiver received energy is converted into electrical power from the electromagnetic to electric power. Then the battery will charge. After next, the payment is next.
Key components which the parts we have in. First is Arduino meter and servo motor and IR sensor for the and lithium battery for the car charging and battery volta, lithium ion battery and RDIF module and key relay motor and wireless power transmitter and wireless power transmitter.
ARL visibility and future growth. Current ARL is 6 to 7. Justification. IRS EV charging system have been tested in pilot projects and limited commercial development, but not at all widely adopted due to its complexity. Okay. Yeah, because inside the load wireless, that's costing it high.
Safety. You can enter the underground. So we have if someone may while walking.
Why it is not now used for only small mobile? Why it is not for business? One of the reasons is systemizing sales. What is the point about you are now present? First, intelligence is when
traditional farming methods are today I'm here to present about the IoT-based intelligent farming system for sustainable and efficient agriculture. Agriculture plays a role of the efficient development of the country, but the traditional farming methods suffer from inefficiencies such as the improper irrigation, lack of real-time monitoring, and with the rapid growth of this technology, IoT has emerged a powerful transforming for the smart agriculture. This project represents as the design and implementation of IoT-based automated crop monitoring and irrigation system using Node MCA for real-time data-driven smart farming. We used hardware and the software sensors like capacitive soil moisture sensor, LoRaWAN module, solar panel. We use LoRaWAN module for communication long range in the Nidhi region, and software Flitter, Google Cloud platform, machine learning algorithms. We use Flitter for providing the farmers to easily available to detect crops. And the main technical feasibility of this project is uses driven low cost of the cell components.
model is there? So for what purpose, like, how exactly you are utilizing what is the outcome?
So actually, we have to decide for farmers' purpose to easily available for the farmers, to easily identify the crops disease.
What? Disease?
Yeah.
What disease? No, it's proposed solution. Now, how are you going to detect the disease in the crop?
So actually, we have to use the sensors like ESP, ESP.
This is the model, data acquisition model. Sensor is the problem. It's sensor in the what is the